Hello and welcome to YourPedia. My name is Aman Sharma and I am your mentor for CSC at YourPedia. So today we'll be solving a question asked in HPCL interview, and the question is from data structures and linked list. So the question is, you have been given a linked list of 6 nodes. There are 6 nodes in the linked list and you have to delete the 4th node. It's a pretty basic question, but the thing is, they have asked all the steps that you need to take in order to do this. So let's try to solve this. Now this is a linked list of 6 nodes and we have to delete the 4th node. So this is the one that we have to delete. Now surely there is a head pointer here. Let's say that the name of the head pointer is S. We are at S and we have to delete D. So in order to delete D, the first thing is that we need to reach C first. This is the state that we need to reach. Now in order to reach from first node to 3rd node, we have to jump twice. So we have to use S of next 2 times. So they have only asked the pseudo code. Like you have to give the pseudo code for this, not the entire code. You have to just tell them the algo. So first of all, the first thing that we will do is, for I equal to 1, I less than equal to 2, I plus plus. We will make 2 jumps here, and the first and most important thing that you have to do is, you have to store the S address in some other address S1, because if you move S from here, then you will lose the address of A, and if you move S here, this linked list will be destroyed, or you can say you will not have any method to retrieve these 2 nodes back, because you have the address of the next node, not the previous node. So you cannot do just like this, that and S is equal to S of next. No, you have to store the S in S1 first. So S1 will have address of S. The address of S is 1000. So what we will do is, we will push the S node to the next. So when S1 is equal to S1 of next, when S1 is equal to S1 of next, so S1 of, what is the S1 of next? Next of 1000 is 2000. So the address stored in the S1 will be equal to 2000. Now when the I value is 2, again the condition is true. So again we will run this code, because the 4 condition is satisfied. Now again S1 is equal to S1 of next. Now S1 is what? 2000, and next of 2000 is what? 3000. So the address stored in S1 will be equal to 3000. So S1 will be pointing to the 3000 node. Now you have reached 3000 and you want to delete this 4th node. Again, after this, we will store the address of the node we want to delete in some temporary node, or you can say temporary variable. Temporary variable will be equal to S1 next. So S1 is 3000 and the next of S1 is 4000. So we will store that address in temporary. Why we will store this address in temporary? It is the most important part of this question, because in the end you have to delete the node. So why temp? Let's see. So now we are at S1 is pointing here and T is pointing here, and we have to delete this node. In order to delete this node, what we have to do is, we will point this S1 directly to the, 5th node. So in order to do that, what we will do is, first step is, we will put the value of temporary next in the S1 next. What we have done is, in S1 next, the next of S1, we have inserted the value of T of next. So what is T of next? T is what? 4000, and the next of T is 5000. So we have inserted 5000 in S1 next. So when we change this, that S1 next will be equal to 5000. What we are doing is, we will be crossing this link and we will be joining this directly to the fifth node. Now this link is broken and the linked list will act like this. Second thing what we will do is, we will put null in the T of next. What do we mean by that? We will put null in the T of next. Now this is T. In the next of T, we will put null. So this means it will not contain any address. If it is not containing any address, this link will also be broken. So if this link is broken, now the linked list is A, B, C, E and F, and this node is not connected in any way to this linked list. Now the third and foremost important step is, we will free T. Now what is free T? Now let's say that you have deleted this node from this linked list, but this node is still having some memory. D is stored in this node. Now this D is not in use. You are using the memory of this block, but you are not using this block. So this block will be present. This block D with having null as its next will be freely roaming in the space. This is called memory leakage, and this node will be called dangling pointer, because it is not pointing to anyone. It is consuming some memory. We are wasting the memory here. So the important step is to free the memory, and this is how, when we free this memory, it will not be present in the space and the linked list will be looking like this. So this is how you delete a node from the linked list, by changing the value of next present in the previous node. So I hope you understood the question. Keep following and keep watching for more interesting questions like this. Thank you.